hopefully a few more people will find their way here. My name is Seth Proctor. I'm the CTO at NuoDB. If you'd like to learn more about what NuoDB is and what we do, we've got a booth just right back here behind us. Look for the green and white cranes in all their resplendent glory everywhere. What I'm demonstrating today is a couple of things. It's pretty exciting because this is a new release that has just come out this week. It is our Swifts release, Swift being a kind of bird, again with the bird themes. What I'm demoing today is a little bit different if you're used to seeing database demos, because I'm not going to show you something that illustrates raw transactional throughput. I'm not going to show you something about latency of queries. I'm not going to show you something about the SQL we can do. What I'm actually going to do is show you a completely different piece of our product, which is really focused on the operations model. And I'm going to use it to talk a little bit about why scaling databases in the cloud is challenging, why building your applications on top of infrastructure that is designed with this in mind makes a difference, and what you can do with NuoDB that really simplifies your programming model, your operations model, in the end really simplifies your entire development environment. What you have on the screen in front of you is our new graphical console for managing NuoDB. And if you haven't looked at NuoDB before, what it is it's a relational database, fully transactional, SQL, ACID compliant, all that good stuff, that's designed around a fundamentally new architecture. An architecture that is built as a peer-to-peer model, where there is no central coordinator, there's no master, there's no notion of sharding your data or explicit replication. It looks to a developer, it looks to a DBA as a single logical database. But it's made up of peers that can scale out on demand. And those peers are basic building blocks that let you solve problems around transactional throughput, around availability, around latency, around reacting to failure, handling live upgrade, kind of other tasks that you're going to care about as you actually take something into production. And those peers can play one of two roles, as we'll see going on. They can provide data durability, or they can run in memory and actually be the peers, be the processes that clients connect to and that drive transactions through the system. And so you really have two different ways of thinking about scaling the system. You have independent points of safety, of durability, of guarantees of where your data lives. And then you also have the ability to scale where transactions are being run and how many clients you can handle as an in-memory problem. And so that's something you can work with very efficiently. This is a really powerful architecture. It lets you solve some really interesting hard problems, but it is a distributed system. And for any of you who have touched scale-out distributed systems, for any of you who have worked in multi-cloud environments, these can become very complicated. And so a big piece of what I'm showing you today is why we've put a lot of effort into this product, not just into the core architecture to be able to solve these fundamental database problems, but also into the front end of the system, into the provisioning model, into the operations model, into the management model, because we fundamentally believe that that's as important to making software scale as the core architecture itself. And so that's what we're looking at here. This is a single web client that I have running. And from this client, I can look at information across a collection of hosts that I've provisioned. So before this demo, I provisioned a dozen hosts, which means I didn't start a database anymore. I just got my software running on these hosts. I made them available to work with from our management tools. And everything you're seeing here, you can do through this GUI, you can do through a CLI, you can do through REST calls, you can do it through Python APIs. It doesn't matter. It's something that you can use our tools for, or you can plug into your tools. But from a single point with security enabled everywhere, so everything is by default secure, usually authenticated, I'm able to monitor everything that's happening across these provision hosts, right? So I can watch kind of standard systems administration things like CPU, like memory utilization. I can pull out a new metric if I want and see something like network traffic, for example. And I can break it down in different ways, I can relate it in different ways, but I get a very simple place to be able to start asking not just traditional DBA questions, but the traditional systems administration questions that I also have to ask to be able to administer a system like this. So this is all about resource utilization. And since this is a database product, the next thing you might want to do is actually start a database. And so what I'm going to walk you through is a feature that we've brought into the GA release of our database as of this week, something we call templates. And templates are basically, they're an SLA. They're an ability to start a database not by defining all the command line flags and the specific amount of cache and the disk space and the number of clients and which engine you want to use and whatever else. It's a way of declaratively stating the problem you're trying to solve and let us build that database and run it for you and monitor it and manage it. Just like SQL is a declarative language that frees you from having to explain exactly how to do a query, it just lets you express what the problem is you're trying to solve. So we're going to go over here, and we're going to add a database to the set of hosts. And if you've ever used Amazon RDS or a similar tool and you've wondered why it's like 5 screens and 80 questions ahead of time, we feel your pain. And so this is really what I think a wizard should look like, right? How do I start a database? I give it a name, I pick some initial credentials, and I pick a template, right? And let's start simple. Let's say you just want to kind of kick the tires. You want to get up and running. So I'm going to pick the single host template, which, as it says, starts just 2 peers. It's a very small database. It provides durability. It provides that in-memory ability to drive a database. I'm not going to override any of the defaults. I'm just going to say start a database, get it running. And what our software is going to do is it's going to go off and it's going to find the place where we're supposed to be running this. It's going to get the right processes running. And now we have this database running. And it's a process that is, it's a database that is distributed in the sense that it's made up of 2 peer processes. It's only running on 1 host at the moment, but we now have a database that looks to a developer like any other relational database. If you've programmed to Oracle, to MySQL, to Postgres, SQL Server, DB2, this is just a SQL database. It can do all the same things. It's a single connection string, JDBC, ODBC, .NET, Node, Python, Ruby, whatever it is you want to talk to it, you can just talk to it. It's just a database. But it's made up of these 2 peer processes. And if you want to use our tools to dig in, you can learn more about where the processes are, what resources they're using, how healthy they are. But at the highest level, it's now just a database that I can monitor as a database, right? There's no activity against it right now, so I realize 0 commits per second doesn't look like much of a heavy lifting application. But I'll invite you to go by our booth afterwards where we've actually got some actual load running against a database, and we can show you. This is a database that is designed to handle very, very high transactional throughput rates, competitive with any of the commercial databases that you may have worked with. But because it's a single logical database, I can talk about the total throughput just in this one point. I can monitor it just in this one point. And I can do some other interesting things too. So let's say you've got this database up and running, and time passes, and you kind of want to do a little bit more with it. You want to understand something about the failure models. You want to start playing with it operationally a little bit more like you would actually do it in deployment. But you don't want to affect this running database. You don't want to have to break anything, take anything down, disrupt anything. So I can go in here and I can edit this database. And I can now say, you know what I want to do? I want to change from that single host template to something different. And so in this case, what I'm going to do is I'm going to change to what we call a minimally redundant model. And what this does is this changes the SLA to say that this database is one where any process, any host can fail, and you still have full access to your data on disk, and you still have full access to the database itself. So I'm going to say, go ahead, submit. And our software is going to go off and figure out how to do that. And what's going to happen is this database is going to change its configuration. There it is. So it's now made up of 4 of these peer processes. It's now running on 3 hosts. And if you want, again, you can drill into that and understand something about exactly what's running and where and why. Or you can take the SLA in the spirit it's intended and say, you know now that any one of those 3 hosts can fail. Any one of those 4 processes can be killed, and you've still got a running database with complete access to your data. And what I just did is a real operational thing. You can do that against a running database without taking down your software, without changing anything about what's running. It's able to just simply do those kinds of upgrades and changes live online. Now, I'm doing this demo right now, actually live in Amazon. This is on fairly small instances. These are R3 large instances. These are memory optimized, but fairly small, fairly inexpensive instances. This does not require kind of massive hardware. That's the point of the cloud, get to commodity. But we can see here that I've actually provisioned hosts in 3 regions in Amazon. This database we've been running just now is here in US East. I'm East Coast, so my bias is always to start things on the East Coast. But so this database right now is running in the Virginia data center. But I've got hosts provisioned in US West 1, which is here in California, and US West 2, which is up in Oregon. And you can see there are no databases running there right now, but I've got those resources available, right? Which means I can now go back to this live running database and I can say, you know, time has passed, this is pretty cool what I've been doing, but what I really want to do is I want to serve my West Coast customers, and I want to give them the same kinds of low latency access that my East Coast customers get. And so again, I can go in here and I can say, edit the SLA, and now let me pick a geo-distributed template. Let me pick something that has minimum SLAs about running not just in one region, but in multiple regions. And again, click submit, and let our engine go off and think about this for 5 or 10 seconds. You're going to get some information as it goes along saying that we've changed the definition, but we're not currently running at the specification you want. And then eventually what it will do is it will finish running. Just accelerate it here. Did I just lose my internet? No, there we go. It finishes running, and there it is. What I've just done is take a running database service live with no interruption to the application, and I've now expanded it by changing the definition so that it's actually now running in all 3 of these regions. And this is real, this is live. This is now a single transactionally consistent database. Looks like a single database, no sharding, no notion of active-passive replication, no like read delays when you do updates. It's a single database, but it's now running in 3 data centers on 2 coasts. It's running across 12 hosts, and it's made up of 16 of these processes. And the idea is that now any number of these hosts, any number of these processes can fail. One of these data centers can go down completely, and the database is still available. And if you have users on the West Coast, and they're doing typical operational things, they can run against the same database that your East Coast users are running against, and it's a single database. But both your East Coast users and your West Coast users get good low latency access for most of the kinds of common applications that we want to run here today. And again, everything I'm doing here, you can script. So that starting a database is a single REST call. Changing the SLA is a single REST call. Deciding to author your own template that defines new rules and new SLAs that you want your database to meet is a single REST call, right? Or a single Python call, or a single invocation of our command line. And so what we've done, what we've worked very hard at, is to build a database that can do something pretty incredible, which is actually run in multiple regions and look transactionally consistent. But make sure also to build around it this management tier that simplifies the problem, that really gives you a database as a service. And at no point did you have to say, this is a database that's going to be 200 gigs. At no point did you have to say, this is a database that, you know, I need to be backed up in some specific way. At no point did you have to kind of predefine your requirements. And that's the important thread here, is this is software that gives you the ability to really evolve and define what you want as your needs evolve, and as your applications evolve, as your company evolves. And so this was a fairly short demo, but I hope it was interesting to the folks here who are watching. And I think if it was interesting, I hope you will come by our booth. We'll be here today, we'll be here tomorrow. Come by, feel free to ask us questions, ask to see a deeper demo. If you'd like to learn more about how the core architecture works, we're happy to talk about it. And of course, if you want to get up and running, we'll point you in the right direction and get you cranking against it. So Does anyone have any questions before I finish here?